Hello guys, and welcome back to our YouTube channel. In our previous videos on the STL library, we talked about vectors which fall under the category of sequential containers and stacks and queues which are both examples of container adapters. Today we are going to talk about set and unordered set, which are an example of associative and unordered associative containers respectively. Okay, so associative containers use the concept of key and key value pairs. We use the key in set and we use the key value pairs in map. Now the main question is that what actually is a set? Well, set is a type of associative container in which each element is unique, just like the set that we study in mathematics. Now as all the elements are unique, we use the value of these elements itself as the key here. Another point to note here is that once a value is added, it cannot be modified. A new value can be added, a prior value can be deleted, but the value that we have added cannot be changed or altered. Also, the data in a set is always stored in a sequential manner or in a sorted format. Another thing is that the time complexity of set operations is of the logarithmic type. So the time complexity is logarithmic time complexity. Now let us take a look at some of the basic functions, basic set functions. Okay, so these are some of the basic set functions. Moving on, now let us take a look at unordered set, which falls under the category of unordered associative containers. This unordered set uses the concept of hashing to store data in the memory. Okay, and just like our normal sets, each and every element in these unordered sets are unique, but the main difference is that the elements are not sorted in the unordered set. Okay, this is the main difference between ordered set, normal set and unordered set, as the name suggests. Okay, and all the operations take a constant time in the unordered set, and if the hashing is not done properly, this constant time complexity can be changed to a linear time complexity. It all depends on our hashing function. Okay, now let us move ahead and take a look at the coding part. Now let us take a look at the coding part of sets. Okay, so this is the basic syntax of set. This is the keyword over here, this is the data type, and this is the variable name. We have declared a simple set S, and let's first insert some values in the set. I'm inserting 10, then 30, then 20, then 40, then 50, and then another 50. Okay, so and after that, just like in a vector, we are using an iterator to iterate over this set, and we are using this iterator to print all the values in this set. This s.begins provides us with the first iterator, and the s.end provides us with the last iterator. So this is the initial and last value of the loop, and this loop is going to print all the values in the set. Okay, so what is the output going to be? The output is going to be 10, 20, 30, 40, 50, and 50 is going to print just once. Okay, let us execute this program, and there we go, 10, 20, 30, 40, 50. Okay, the duplicate value is not printed. Okay, so yeah, another thing, if this is sorted in an ascending order, but we can also change that. We can change it to a descending order like this. Okay, now let me just run this again. So yeah, we can also sort the list in a descending order. Okay, let me just remove this. Okay, so now let us take a look at how to remove elements from a list, from a set. Okay, so the first method by which we can do this is by passing a value in the erase function. This s.erase helps us remove the values from a set. So we're going to try and remove 50. Remember that our set has 10, 20, 30, 40 and 50 in it. We're going to remove 50 from it using this s.erase function. Okay, and again we're gonna just print our set using this loop. Let's run it again. Okay, after removing 50, our output is 10, 20, 30 and 40. Okay, this is pretty simple. Now we can, another method to remove values in a set is by passing the iterator. We're going to try and remove all the values that are less than 30. Okay, so in this s.erase function, we're going to pass the beginning iterator, and we're going to use this find function to find the location of 30, and this s.erase is going to delete all the values that are less than 30. Okay, then again this loop is going to print all those values. Let's run this again. Okay, removing the values less than 30. So in 10, 20, 30 and 40, this removed 10 and 20, so we're left with 30 and 40 only. Okay, another function that we're going to take a look at is this empty function. So if s.empty, if this condition is true, it's going to print the set is empty, and if this condition is false, which it is, our set has the values 30 and 40, it's going to print the set is not empty. Okay, another function over here is this size function. This returns how many values are there in our set. So currently there are 30 and 40, there are two values in our set, so the size is gonna be 2. Okay, I'm just gonna comment this for now. This is gonna delete all the values in our set. So let us run this. Okay, the set is not empty, so yeah, this condition is false. So else runs, the set is not empty, obviously it has 30 and 40, and 30 and 40 are two values, so the size of the set is 2. Okay, so finally we have another function, s.clear. It deletes all the values in our set. Okay, so we're gonna check the size of the set after deletion. It's gonna be 0, obviously. So let's take a look. Yeah, the size after clearing is 0. So these are some of the basic functions in a set. Now let us move on to unordered set. Okay guys, now let us take a couple of basic examples of the unordered set. This is the syntax of unordered set. This is just the same as a normal set. This is the keyword, this is the data type, and this over here is the variable name. I am giving the values to the unordered set right here only. So the values that I'm giving are 4, 2, 3, 1, 1, 2, 3. Okay, so just as I told you, the duplicates will not be considered and the data will be randomly stored. It will not be stored in a sorted format. Okay, now, and this is just an iterator just like before, and I'm traversing and printing on the unordered set. Okay, let's take a look at the output. Yeah, so there we go. 1, 3, 2, 4. No proper sorting is done. It's printed in a random order. Okay. Now moving on. Yeah. Now I've declared another unordered set of the type string. Adding the values A, B, C, D, and E to it. And this is an iterator, and I'm just printing it here. Now let's take a look at the find method. Okay, we're taking a string key as E. Okay, and we know that E is in our set. E is in our unordered set. Our unordered set has A, B, C, D, and E. E is in our unordered set, so our key is in our unordered set. Okay, now in this if case, I'm giving unordered set dot find key. Okay, what this find method does is, if the key is in our set, in our unordered set, the dot find method will give us the iterator to that key. Okay, and if the key is not in our set, it will return the iterator of the last value in our set. Okay, so if unordered set dot find key equal to unordered set dot end. That means that the value is not in the set, okay, not in the unordered set. So we're gonna print not found. Else, if it is found, we're gonna print found. Okay, now let's take a look at this. Let me just print this. Yeah, so it's gonna print CADP in a random order, and it's gonna print found E. Okay, because E is in our unordered set. Now just let us put a random key, let's say Z. Gonna try and find Z in our unordered set of A, B, C, D, E. Okay, obviously the answer is gonna be not found because Z is not in there. Okay, let's try and run this. Yeah, cannot find Z. Okay. Yeah, so these are some of the basic functions on a unordered set. All the rest of the things are same as the ordered set. So thank you guys for watching this video, and please take a look at our different playlists. We have a machine learning playlist on our channel. Please do take a look on it, and stay tuned for more videos. Thanks for watching.